Hello, welcome everybody to today's GMAT Day extravaganza. It is an extravaganza, and so I'm here to be extravagant with you. I see you guys in the chat window, and I'm going to keep paying attention to that. If you have questions, ask them all the time. Questions make this whole thing fun. All right. So what we're talking about in this session is how top scorers think differently. I don't know that it's super different from everybody else, but just kidding. It is a little bit different. So I'm going to explore basically what's going on in kind of the back of my mind as I look at problems and how that translates essentially to success. And I'm going to build on something that I just talked about a couple of weeks ago. We're going to start from this, and that something is inference. All right. Had a session on inference a couple of weeks ago and made the case basically that everything on the test is inference, and it absolutely is. And the part that I want to focus on this time is purpose. Understanding why an author has included information. Now, when I first talked about it, I talked about it largely in a verbal context or like a data insights logic context. Touched on math a little bit. This time, I'm going full quant on it, all right? Or, largely quant. Understanding why stuff is given to you in a problem, understanding why the test is giving you everything is basically the most fundamental skill that you can develop that will lead to great success on this. And when you really get down to why you're having trouble, especially starting off on questions, it's going to be about understanding why you were given anything at all, right? Basically, you want to think of these problems as puzzles, right? And think about a puzzle, right? Traditional puzzle, say 500-piece puzzle, jigsaw puzzle. You get that box, you open it up. On the front of the box is this beautiful image, and you're like, I can make that because I got all the pieces right here. And you do. But actually making it is a little bit trickier, right? Because you got so many pieces in front of you on the table, and they've got all these different shapes that are kind of similar but kind of different. And making the puzzle is about finding a piece to latch onto. How many of you start with like a border piece? Does anybody even do puzzles anymore? I don't know. And then finding a piece that kind of matches that piece's shape to put next to it, right? That is what is going on a lot of these problems. They give you all these little pieces, all these givens, and you're supposed to figure out, okay, which givens actually go directly together? Which ones are a good fit for each other? Because it's in putting things together, synthesis, that you manage to start making progress in these problems, all right? I'm going to take it first off on a quant problem, step by step, so you can see how this process works. And again, ask lots of questions. Maggie, I love puzzles too. Like, you're going to be great. The GMAT mindset for top scorers is basically, this is a fun puzzle game, and we're going to do it. All right. So this problem starts this way. Set S contains 7 distinct integers. Now, anybody who's done any of these problems will likely tell you, at the very beginning, you have no idea what to make of information. And the GMAT often leads with information that is not all that impressive, important, certainly not all that concrete in the beginning, right? They start kind of generally, do some table setting. But usually that first sentence contains at least a nugget of important information, right? If I'm reading this, I see set S contains 7 distinct integers. The thing that jumps out at me about it is 7 and integers, and that it's a set. Now you might notice there, I didn't mention distinct, because if I'm being totally honest, I know it's there. I know it's important. Like, I know why it's given, but I don't really notice it on the first read. That's something I'm going to come back for. One of the things that I can guarantee you every top scorer does, reread problems, because the GMAT's thing is to present information in such a way that, like, you're getting information that is useful before you know its use. You're only going to know the utility of this information after you've seen the rest of the problem. And that's why rereading can be such an important step to your problem-solving process. All right. Right on, Anissa. Distinct integers can absolutely be positive, negative, non-negative, which would be positives plus 0, right? So anything on a number line would be integers. Distinct, of course, means different. But again, I'm not thinking that. I'm reading this, I'm taking in 7 integers, and there's a set. So I know I'm getting some sort of set situation coming my way, and they're going to have to describe something about the set. They'll use things like range or median or averages. But I don't know until they tell me. They could go an entirely different direction with it, right? So I read on to the second sentence, and indeed they do go statistics. And that's what I'll notice right away. The median of set S is the integer m. Cool. So in my mind, I've got these kind of like 7 spaces, right? And m is in the middle of them. And I know that once I finish reading the problem, if I start working on it, I can draw it out like that. I probably will draw it out like that as I'm doing the problem. But all I'm registering now is m is in the middle spot, right? I might go so far as to think it's in the 4th spot, but middle spot's good enough for now, because when I'm first reading this problem, I'm just trying to get a sketch of the information, right? Looking at those puzzle pieces and saying, okay, which ones are at least the same size? Which ones should I kind of group together? Which ones have the similar sort of colors on them, right? Just to start pulling things together. And all values in set S are equal to or less than 2m. Reading that, I'm saying, okay, so 2m's probably bigger than m, assuming m's positive, I guess. Now this has kind of told us that m is positive, right? Because for m to be less than 2m, can't be 0, can't be negative, right? I don't know that I specifically register that when I'm reading it. I'm partly thinking of it because Vanessa is pointing out that integers can be lots of things, right? But I am seeing that I've got kind of an upper limit on this. Everything is equal to or less than 2m. And I'm also making a note of equal to or less than, but it's also the sort of thing I might come back and fix on post. On rereading the problem, I might just initially read that as less than 2m. And when I'm rereading, I see, wait, equal to or less than, because that is an important distinction that makes all the difference between getting some problems right and getting them wrong, right? So just getting a sketch of it, I know they've told me something about the median of the set. I know they've told me something about every member of the set, but that every member of the set feels uncertain to me, right? Less than or equal to 2m is kind of a big range. And then they pop the question. Hey, thanks, Shabazz. What's the highest possible average, arithmetic mean, of all values in set S? Now, I ignore arithmetic mean because that's the only kind of average they really talk about on the test, but they will usually say it at some point. What I'm super focused on in the question stem, the question stem is when I really start to pull focus. The highest possible average. And it does say of all values in set S, thank goodness, not like the top 5 values or something, because they can throw that curveball there, but what's the highest possible average? Now, here's where the inference stuff really begins in earnest, right? Because this is the question stem. This is the fundamental thing they want to know. And just like you would in data sufficiency, in a quant question, you want to look at that question and think, okay, what do I need to be able to figure this out, right? To get the average of all values in set S, I need to know all the values in set S, right? That's 7 values, as I recall. And so far, I only know the median and this like general thing about the other 6 values. But for it to be the highest possible average, that pushes this problem into optimization territory, max-min territory, right? So when I see that, I know, okay, I shouldn't be too bothered about all the uncertainty they left in this problem. 7 values, and they told me exactly one of them, and it's M. I don't need to worry about that because in a highest possible whatever, lowest possible whatever, least possible whatever sort of problem, I know I'm expecting to make assumptions. Now, that right there comes from just knowing your problem types. And fundamentally, the starting point in doing these problems well is recognition, something to latch onto. You're going to recognize things like median, right, and average pretty well. Those are like bread and butter things for the GMAT. But seeing highest possible average and thinking, okay, I know what this fits in with. I know what kind of stuff is expected of me in this problem. I know what kind of tricks they have in this problem. That goes a long way. And that's what a lot of you are going to be studying for in like the early and middle stages of your studying. Just like, how do I know what the problem wants from me? All right. It usually comes from the question stem. The question stem is the most important kind of driving force in the problem. And so again, just like you would in data sufficiency, you kind of start there and think, what do I need? I need all 7 values. I know it's highest possible, so I also need to make certain assumptions. At that point, I'm going to look at the answer choices because before I write anything down, you guys, I'm looking at the whole problem, reading the whole problem all the way through. Again, just trying to get a sketch, not trying to memorize everything, not trying to note down everything. Just trying to get a sketch in my mind about the dynamics here. In my mind, I've got 7 spots, M's in the middle, and I want to up the average of this whole thing. And I know there are more details in there. I'm coming back for them, right? I see that these answer choices are variable expressions. And I say to myself, okay, If I want to pick a number for m, I can pick a number for m here, right? That'll work. You have variables in the answer choices. You can do it. Now, that's thing number 2. You read a problem, you kind of get a sketch of it. You see what's required of you, right? This one's the highest possible thing. I'm thinking max min stuff, and I see the answer choices. The next thing is thinking over your options. In a word problem, you tend to have at least 2 options. Generally, there's a algebraic approach, and there's some kind of numerical approach. Sometimes there's like a pure logic approach or something like that. And I'm not saying it's not here for this problem. I don't know what it is. So in my mind, I'm not going to waste any time trying to think about that if it's test moment. I'm thinking algebra or numerical. Which one do I like more? And my thought is, I'm pretty comfortable doing something like this algebraically. So I'm just going to go ahead with algebra. It'll get me directly to one of these answers. I won't have to plug in my number to the answers. I don't see a number totally helping me anyway, because really the challenge here is in filling in the blanks of this thing, these like unknown values that they've left us with, right? So you might make a different choice. That's totally fine, but it has to be a choice. If you're going to do this test right, it has to be a choice you're making before you even start writing down stuff from the problem, for the problem. One thing I notice about people is they have a tendency to just take notes as they go through the problem, but it turns out the form in which you take those notes, like let's say you take them algebraically, let's say you take them more numerically or more in words or something, ends up guiding maybe a little too much how you try to solve the problem afterwards. It should be a decision. It should be a decision with a sketch of the problem in your mind. It should be a decision based on what you've seen in previous problems, what you know your strengths are, what you know your weaknesses are. I know I'm okay with algebra. I'm going to go ahead with algebra on this one, right? And yeah, it totally is C, guys. Spoiler alert. Can't draw straight lines for the life of me. And it turns out that's something you just have to live with for your entire life. But there you go. I've got M. I'm looking for the highest possible average, which now I start thinking about in earnest. What's going to make this the highest possible average? For all these unknowns, I'm going to have to make a certain assumption. It's a max-min problem, and I'm going to assume the highest value possible for them, because the highest possible average of a set depends on that set having the highest possible sum that it can have, right? What's going to give it the highest possible sum? Biggest numbers I can put in this set. And then come constraints. Okay, so I've got my kind of like driving motive now. I want the biggest numbers I can put in this set. I'm going back to the problem now and I'm rereading and I'm saying, what did they tell me about the biggest numbers here? Now, this piece of information becomes actually useful. All values in set S are equal to or less than 2m. Now, 2m seems bigger than m, and I'm going to assume it is if I'm trying to maximize this. And it must be, because they're all equal to or less than 2m. I guess it could be 0. So I'm going to put 2m over here as the biggest thing. Now, my second thought is, could I make all of them 2m? But constraints, right? I can't make these ones 2m, because then they'll be less than the median, right? And the median will cease to be the median anymore, right? But theoretically, I could make these ones 2m. Here's where I'm checking the problem one more time. Question I'm going to the problem with is, wait, can I make them the same or do they need to be different? And that's when I reread the beginning of the problem and see set S contains 7 distinct integers. And I say, okay, well, I would want to make them 2m, both of those. That would be the maximum, but I can't. And so I'm going to make them the maximum they can be without being 2m and still being integers. 2m minus 1, 2m minus 2. And yeah, that... Kajal, that, oh yes, distinct thing is exactly it. Like, I genuinely, when I like redid this problem preparing for this session, genuinely forgot about the distinct integers thing, but I'm so much in the habit of rereading the problem and of like asking myself the question, can they all be 2m? I'm not sure. And just kind of relying on the problem for information, that it's not such a worry. Like, you don't need to take all the information in initially if you're committed to going back to the problem. And a lot of people will say, yeah, but you can't. You got to reread. It's going to take so much time. I guarantee you people waste more time not going back to the problem and just trying to like remember or invent a next step in a problem than they would if they just went back and reread a little bit. It is honestly that important. So 7 distinct integers, that's the biggest they can be, but all these other ones have to be m or smaller. And of course, the trick is smaller in this case because they're all distinct. And so m minus 1, m minus 2, m minus 3. is where that whole thing goes. And now we've got it filled in. We've done the hard part, right? Hard part in an optimization problem is filling in the extra blanks that they're basically going to leave for you in these problems, right? But going into it, having recognized it's that kind of problem and having that expectation, you're pretty unstoppable at that point, all right? Now, all you have to do is add them all up and divide by the 7 terms you have, because at this point, it's just a straight up average. I mean, be careful with your M's. We got 1, 2, 3, 4, 6, 8, 10 of them. And we can start seeing C very much emerge as the right answer. But then we've got all those other numbers, -3, -2, -1. It's -6. And then -2, -1 again. That's minus another 3, so -9. And the average will be that over 7. Notice each piece is kind of its own problem. Each piece is its own thing. I start from the question, think highest possible average, and it turns out highest possible is a very different kind of coded set of instructions than averages. Average is quite easy to calculate as long as you have the things, but knowing what things to put in there, that's inherent to the highest possible, and that definitely takes some effort, right? How to avoid errors like missing distinct integers, Victoria, is really, really the question. For me, it's rereading the problem. I would say I typically read the problem, I should say, 3 times as I'm going through it. Once, that first time to get that sketch, and I'm involving the answer choices in that, right? Coming up with a plan. Second time, at some point in the middle of working the problem, right? At some point, like when I had, M there and didn't know what to put in the rest of the blanks, I'm coming back to the problem. I'm saying, what did you guys say again? I know I want to maximize, but do I have an upper limit? That sort of thing, right? And then usually one last time when I'm about to click an answer or I've clicked an answer, and that time I especially want to be sure I've answered the right question, because as you guys will know, they can get tricky in how they ask the questions. I might reread the whole problem then, or I might just read the question stem and like make sure they've asked for X and I'm answering for X, as opposed to they've asked for Y and I'm answering for X, or that sort of thing. Because it is very much an attention to detail test, right? You have to get all these details down. And yeah, the best way I found is rereading the problem. Notice though that what prompted me to reread for distinct was that moment of doubt where I was like, okay, I know 2M can go there. Can I make both of those other ones 2M as well? That's partly drawing on experience with these problems. I've seen another problem like this in which you can make all of them the same, or like all the high ones the same and all the low ones the same, right? And so I know that can happen sometimes, but I've also seen some in which they have to be different from each other. And so when I get to that filling in place, I've almost got that moment of ambiguity built into me. Like, wait, do they need to be different or can they be the same? Where I think a lot of people will just assume one thing and go for it, right? And that might indeed be the boat that you find yourself in as you're doing this problem, right? Rereading can really help with that. But the mindset with which you reread is also important. Notice I came to reread with a question in mind. Could they be the same or do they have to be different? And then distinct's going to jump out at me, right? But even if I didn't do that, for instance, when I initially read it as less than 2M, and I came back and I reread it, again, when I was doing this earlier, as less than or equal to 2M, that sort of thing, I didn't necessarily think to ask myself at all. I was just like, oh, 2M, less than, I've got a range, I'm paying attention to that. But if I come back and I reread with an open mind to, I probably missed a detail in there, let me see if any of these details make sense. That reread is different from the first read, because at that point, you've already been dealing with the problem a little bit, right? You've already had some experience with it, and you already used some of the givens, right? The median's in place, for instance, when I'm rereading. And so I don't need to worry about that piece of information anymore. And that gives the other little pieces of information room to breathe, right? Once you've sorted out this 2M thing and the median thing, then all there really is to reconsult is the first question or first sentence in the question stem. And that's going to draw attention to the distinct as well. But it comes to rereading. It comes to rereading with an open mind, a mind open to the fact that you may have missed details that you really need, and basically incorporating that information, right? It is C, by the way, just in case there was any doubt left at all. C is absolutely the answer here. And it is exactly that, the sum of -3, -2, -1. All those basically numerals, all those non-M terms, when they add up, get to that -9. Yep. And thank you, Shiva. All right, awesome. So how does this translate other places? On critical reasoning, it translates straight up. Every sentence is there for a purpose, and understanding why each sentence is there, and understanding, again, that puzzle thing, how one sentence fits in with the next, how one sentence is responding to the last, and things like that, inherent to critical reasoning, right? Oh, it does not make sense why you skip other positive numbers. There we go. Got it. Okay, cool. It's in data sufficiency as well. Take a look at this problem. We're not going to do it all the way through, but this is just to kind of model what's happening with this kind of inference-based mindset. In data sufficiency, you start with the question, and the longer the question is, the more you have to piece things together, right? In a certain sport, teams receive 3 points for each win, 1 point for each draw, no points for losses. That's already a lot of information to keep track of. You could take notes on that, but you could just kind of file it away as, okay, it's there. We got win, draw, lose. We got different point values for them. Come back for those exact point values. 5-team tournament on the sport in which each of the teams, GH, JK, and L, each played each other exactly once, each other team exactly once. Again, another important piece of information. We've got 5 teams, right? They've got names, very, very inventive names. But mathematically speaking, the fact that they played each other team exactly once is important. This is where inference absolutely comes into play. And one of the things you can do to help yourself with inference is this. They tend to give you rules in kind of an abstract form, right? This doesn't leap off the screen. Each of the teams played each other team exactly once. But if I choose one momentarily, like G, what I'm looking at there is, okay, team G then played once against H, right? Once against J, once against K, and once against L. G played 4 games. I have no reason to believe that any of the other teams would be different, right? H is going to play 4 games, each of the other teams, G, J, K, and L exactly once, and so on. So when the question's asking, did team L finish the tournament with the highest point total? I know, one, fundamentally they're asking, did they like win/draw more than the other teams, right? Because they're going to get points from winning and drawing. Notice they say point total here, right? But point total is tied up here to win, draw, etc., right? That right there. Again, inference, right? Connecting the dots. Very important in word problems. But I also know then, coming to the statements, that when I see team L finished with 8 points, and I'm adding to that something I've inferred from the question stem, right? Putting these puzzle pieces together, that team L played 4 games. I can break down that 8 points really effectively, because there's only one way to get to 8 points with 4 games and points of 3 and 1 and 0. The only way you can do it is if they won 2 games, giving them 6 points, and then drew 2 games, giving them 8 points, right? Inference and dealing with this test well is basically seeing what they've given you, asking what it connects to, asking why they've given it to you and what it connects to in the problem, and then making use of those connections. A lot of people will not do that. They'll look at that 8 points and say, well, can't do much with that now. Don't know the other team's points. And that's legit. Statement 1 is insufficient. You absolutely cannot do much with it now. You do need to know something about the other teams, but that doesn't mean you can do nothing with it now. And taking it to that next level, like looking at a statement and inferring something else that they didn't say, but that must be true because you've combined it with something else they've said or something like that, that's solving like a pro. Or a pro, I'll put that in air quotes. What's a pro anyway? All right. 2 wins, 2 draws. Second statement, of course, is not sufficient because for all we know, another team had 4 wins or something like that. Second statement, though, the sum of all 5 teams' point totals for the tournament was 23 points. On its own, not good enough to tell us whether Team L finished with the highest point total because, well, nothing about Team L in there. We don't know how many points out of those 23 Team L got, right? So that one's insufficient. But now when you come to combine them, 6 games left with 15 points remaining is what I'm hearing from somebody. And yeah, great question, Eric. That's a fair question, right? So each team plays 4 points. Does that mean that the highest ranking team will have 12 points? What would that entail? Like so asking these questions of yourself is what's going to pull you through the problems, right? Like Eric's question down at the bottom of chat is exactly the right thing to be asking yourself. Do I know whether somebody's going to get 12 points. And that's what leads to, in data sufficiency in particular, case testing as an effective thing. Can I imagine a scenario in which a team or all the teams only get like 3 wins or only get 2 wins or something like that, right? Or does one of them have to win all 4? Can I liken it to similar tournaments I've known about, right? Like you can look at this in the context of maybe like a World Cup sort of situation. And no, I mean, a team like, you could have a team maybe winning 3 times and drawing the 4th one. You could have a team winning twice and drawing the other 2, and have that still be theoretically the score leader for this whole thing. Yeah, it is, by the way, it is absolutely C. I'm going to see if there are questions in Q and A. It does end up being absolutely C. There is like good stuff in the chat window. And again, I just kind of wanted to give you the sketch of how this works. They tell you Team L finished with 8 points. You know that points are mentioned up there. That's the puzzle pieces fitting together. And so you can tie that 8 points to wins, draws, maybe losses. And sometimes you'll come up with like 2, 3 possibilities for it. And it's not necessarily worth laying all of them out there, but it is worth looking at that 8 points and saying, hey, can I get a little further with that? Looking at that 23 points and saying, hey, can I get a little further with that whole thing? All right. And yeah, combinatorics, absolutely a way to go. As people in the chat window are saying, like, you can figure out how many games were responsible for all those points. You can figure out what that means for the point total for each of the other teams. And essentially, it's going to be C. Let's see, Q and A. A few seconds ago. Oh, yeah, no. I very much would, but I am actually running out of time for this session. So this is more, look, here's really the point. Think like a top scorer. It's all about how you start a problem, all right? Taking the information in, you don't have to get it all in right away. You can come back for details, but taking the information in, noticing how things start fitting together, and paying especially attention to the question in quant problems and data sufficiency problems, the keywords in other data insights problems, like the keywords in the 3 statements that you have to decide yes or no for, paying attention for the conclusion in critical reasoning, and paying attention for the connections from sentence to sentence in reading comprehension. All of that stuff is stuff you want to see up front. You want to ask yourself why you've been given information, why the question's asked a certain way, and there are going to be answers in the problem. And then finally, one of the best things you can do is anytime there's a seeming moment of ambiguity as you're solving a problem, you pause, you're like, where do I go from here? I'm not sure about this. Go back and reread the problem. Developing that sense of ambiguity is a little tough. You have to kind of get trapped on a bunch of problems to know, oh, wait, I've been trapped here before. Let me double check the problem. But if you start cultivating the habit of rereading the problems now, partway through the problem, just go back and reread it pro forma, you're going to get good places with the attention to detail on all of this. All right. All right, let's see. There's so many Q&A questions, but I'm going to pick one out from random. How do you improve DI? Score as much as possible. I mean, anybody who's seen my YouTube video knows I struggle with DI too, so I'm with you right now. I think it's about choosing your battles wisely. First off, there's some questions on DI that are going to take you way longer than the other questions and probably aren't as worth your time. And then it's about basically getting faster, and getting faster is seeing the connections between things. Like it comes down to that. MSR is a good example because MSR questions usually make you connect something from one tab to another tab. And if you're always fumbling around for those connections, it's a little tough. But if you note the connections when you're first reading the MSR tabs, when you're like, okay, I'm on tab 2, it's saying this thing. I remember something about that from tab 1. Then you're going to be so ready for the questions. And that just kind of goes throughout the data insights section, at least on the non-data sufficiency stuff. All right. As that is all we have time for. I think I've overrun my time. But thank you for coming out. Really appreciate it. If you have any further inquiries, email me. And thank you, GMAT Club, for hosting awesome sessions as always. Guys, enjoy your GMAT day.